Good morning, everybody. It's Marty, the JavaScript party, and my buddy Rhett. I totally forgot to get her a nut because I've been just like obsessed about something all day, or all night. Ever since yesterday, I've been thinking about delete, and it just sort of. Oh, okay, I thought I'd worked on something else. npm. So I'm gonna start my application up. um, it just made me think about a lot of things about like historically and all that. And delete is a fascinating issue, and I can't even believe I went this many years as a JavaScript developer and never sort of went down this path of trying to understand delete because it is so crazy important. And I remember like in 1995, 96, when JavaScript first started kind of coming onto the scene. I had done like some other coding, like in Java applets, and there was like a VB script that was working in some versions, and then there was like a thing called ActiveX and different technologies that there was like another one, but there was all kinds of different technologies and stuff that were kind of coming on. And most people, most professionals, totally said JavaScript would never work. Like it was a flash in the pan. There's no way it could ever become anything useful. And the reason they said was because of memory management. They're like, it's just you can't manage memory in in JavaScript. And so I knew a little bit about memory management. I wasn't really deep into it because the first language I ever worked in was called BASIC. It was basic language, and it was on a little machine called a VIC-20, which had like 3 megs or 3K of memory. And so you'd write some code in there. And with BASIC, you didn't have to manage memory. But a friend of mine, he got something called a Commodore 64 that looked exactly like a VIC-20, but it had 64K of memory, and you could do a lot of things with it. And he would write code in assembler language. His name was Steve Stevens, and he was a very good computer programmer back in the early '80s. Um, I don't ever know what became of him. We knew each other in like middle school and high school, but we so we the thing was with him was what he would have to do is he would actually have to go to a piece of memory in there, and he would assign something. He would push something to that piece of memory. So he would push little codes and stuff to that memory, and then the codes would map. Then he would use that as reference to do certain things. Sometimes it was like to draw something on a screen or to write some text or whatever, and you'd write that to a piece of memory. I also did a bit of coding where we would write things to a piece of memory, and then we would and then and so you would say, hey, at address whatever, put this information, and then um, and then when you'd retrieve it, you would get that information back, and then like you could, but so you didn't, but for convenience, we started creating variable names. So you'd be like, okay, variable A is actually whatever's in this piece of memory, and variable B is in whatever in this other piece of memory, and variable C is. And so one thing you had to be really careful with was like you could say variable A is pointing to this piece of memory and write this here. So I want to remember like a letter. And variable B is pointing to a different piece of memory, and I want to remember a number. So I'm going to put the number there. And variable C is maybe a different letter. And but if you put it where variable A was, now variable A is that, right? Because they're pointing at the exact same piece of memory. So you had to be very careful to manage the memory so that you wouldn't overwrite other things that other variables were pointing at or whatever. And then JavaScript came out, and I never thought that was a big deal. And then, I mean, I never thought that was a useful sort of thing. And then JavaScript came out, and they just managed all that for you. And they weren't the only ones. There were like other languages and stuff, but a lot of people said that that was a poison pill. Like JavaScript could never really go anywhere because there's no way to know what, like if you say let A equal hello, you don't even know. There's no way to know where in memory that information is. And what to make it even more complicated, JavaScript collect they kind of have a, my understanding is like if you say let a equal this object, then a equals a spot in memory, and then that spot in memory equals all the data that's in the object. So when you delete a, that spot in memory points to where all the stuff in the object is. And so if anything, but if anything anywhere it still has a reference to that object, then it won't free up that memory. And that is the issue that I'm running into right now, is when I go like this and I say add this visualization, and then I go over here and then I say delete this visualization, I think I still have a bunch of references to all the objects that described that visualization. And I know from just personal experience that most enterprise applications that I've ever worked on, if you used them for like 4 or 5 hours, they just slowly get slower and slower and slower and slower. And that is, I've always been told, is because of memory. Like you do this, and then you add another one, and then you delete another one, and then you add another one, and then you delete another one. And now I have like 3 things of massive amounts of data sitting in memory, and but nothing on the screen, right? So like that is that will definitely limit how many things we'll ever be able to show on a screen, because every time I add something, I'm consuming a piece of memory, and every time I consume a piece of memory, like nothing else can use it, so it's going to slow everything down. Now, eventually, if we add thousands and thousands and thousands of things, it will make the application slow. And then the kit, what's the fix? Oh, hit refresh. Hit refresh and you're back to scratch again. So, it's like memory management isn't. So why did it fail? Like, why did the prediction of JavaScript not ever making it, why did that not work out? Like literally 99 out of 100 computer science people that I ever met would say, oh, JavaScript's a joke, it's never going to work. And here we are 40 years later, right? Or 30 years later. And JavaScript, I believe, is probably the most dominant programming language on Earth. So like how? Why were they so wrong? Well, the thing they didn't really predict was how fast memory would go. Like we I don't think they ever conceived of that we'd have gigs and gigs and gigs of memory, just memory. They just didn't perceive that we'd have little devices like this little USB that can hold a terabyte. Like no one predicted that. So I think that's why they got it wrong. But I think eventually they'll be right if if we don't figure out some stuff, because right now all of our applications end up just like they can only get to a certain point before they just don't work anymore, because they get so bogged down and they use so much memory. See, it's 8:48, so I only have 7 minutes. So I have to figure out, okay, how do I delete this thing? Because I was like, oh, okay, over here, we need a visualization ID so I can pass it to the base ST render so I can assign it to the parents array, right? And then the idea was like, if it didn't have any parents, I was going to just delete it. And then it dawned on me, I don't actually know. I don't think there is any way to delete something. What you have to do is you have to remove all references to it. And it's like, well, how do you determine all the references to an object, right? And how do you determine like that you didn't miss one? I don't know of any way to do that. I've never even heard of any way to do that. So like I was just scrubbing my brain, looking through everything to try to figure out how the hell do you even do this? So I guess we have this new technology. I think it's still considered new, ChatGPT. It feels old to me. It feels like this ancient technology that I've been using forever, but I guess it's pretty new. It does definitely explain, this technology explains, I remember there would be these writers that would write like hundreds of books, and they'd be like, how did they do it? Well, clearly these people had access to something like ChatGPT, I think. That's the only thing that explains it to me. They would say that like like R.A. Salvador wrote a ton of good books, and um, uh, they would say that there were like just a lot of people who wrote like them, and so would publish books and under his name. But I don't know. I think it might have been a Chat GPT type of technology um, that would sort of study his books and then write other books like it. But I don't know. That's just a conspiracy theory. Anyways, I'm writing code in JS, and I have large objects, and uh, I just realized that it is actually quite challenging to actually delete an object so that it is gone from memory. Okay, so here's the problem with this is I don't know what I don't know. So this is why I'm giving ChatGPT a very, very general statement. Like, hey, here's my issue. Because honestly, like if I give it any hints as to what I think might be the answer, it's not going to tell me maybe a much easier, more obvious way to do it. So I'm just going to go very general. Okay, so you're absolutely right. JavaScript objects is not as straightforward as it might seem, unlike lower level languages like C or C++. So I remember writing code in C when I was in college for my design uh, design class. We had to take a senior design course. It was like a team thing, and it was four of us, and we were electrical engineers, and I wrote code for it. And I wrote my code in Visual Basic, but there was one sort of thing that Visual Basic couldn't do at that time. I think it was Visual Basic 3, but it might have been Visual Basic 4. It was right between Visual Basic 3 and 4 coming out, and I believe Visual Basic is gone now. I don't think it's supported in any way. But to read the parallel port, there was like this port that you could plug things into called a parallel port that people used to mostly use for printers. And to read that, you had to use C, and you would have to compile a little C project that would write stuff to a specific place in memory. And then it would read from a specific place that looked like memory, but it was actually the port, and it would write to a specific place. And you could write to a specific place, and then my Visual Basic knew how to read a specific place in memory. So so I had to do that. And actually, I think I had to read from memory and write it to the hard drive into a file, and then Visual Basic knew how to read from the file. I think that's how that all worked. But you don't so like unlike lower like C or C++, you don't directly free memory. Instead, garbage collection decides when memory can be reclaimed. The trick is an object is only deleted when nothing references it anymore. Here are the key points to make sure your object can be garbage collected. And see, another thing that just sort of hit me was like so many people like swear that you need to have getters and setters for everything, and that when you get something that you need to create a new object that copies the old object. But copying an object is kind of tricky in JavaScript as well. So, but now I understand why you'd want to do that, because then when you delete it from wherever you do the getter setter, you don't have any references to it. What I typically do with my getters is I actually send a reference to the original object, which means that if whatever it is still existing, it still has a reference to that original object, and that piece of object won't get freed up. Um, but references are what matters. So yeah, we have this reference, big object, data, new array, fill x. So it's like a million x's. The memory won't be freed until every variable, closure, or structure of the reference big object is gone. So if you just say delete big object, it does not delete it. And that is like, I was like, and I will simply delete my object. Nope, that's not how that works. Knucklehead. I can't believe that. It's just so wild that it has taken this long. But I don't know that I've ever worked with anything that was as memory consumptive as this project has the potential of being. Or delete variables. And like I said, I've worked in so many places where we had these massive things, and like the solution is like, oh, every few hours you should just refresh the page. So objects and containers, maps might have it. Setting a big object null won't help. And see, this is what I try to do, right? I have a dictionary I was like, oh, I'll just delete it from the dictionary and it's gone. But then when we looked at the memory, there was still all these objects around, and we were still, our memory consumption didn't go down, or it didn't. I think even after deleting, the memory consumption was still the same. So obviously, I still have that. And who knows? They, like I said, other third-party things might be making references to it. Oh yeah, circular references, and that is another problem. Is like all my objects have objects within objects within objects, and so if any object has any reference to any of those, it's not going to delete it, which is kind of nice because I was like, well, I need to manage whether I delete something if something else is using it. Well, JavaScript just takes care of that for me. It takes care of that part. What it doesn't take care of is actually deleting it when I want it really gone. Um, Closures. So forcing that is not possible. Um, so it didn't have any solutions. Okay, so is there a way for me to add some kind of behavior? So I was thinking maybe I could have a, like, some kind of function that sort of just tells if it's alive, like it does a console log if it's still alive, but if it's gone, obviously it won't be able to talk. So I would actually be able to look in my console and see if that object has actually been deleted, because if it's not pinging anymore, it's not, it doesn't exist anymore. Or some kind of behavior that I could monitor, and if the behavior goes away, I will know that the object is gone. I can't be the first one to think of it. Can I detect when an object has actually been garbage collected? That's tricky because JavaScript doesn't give you a normal event or callback when an object is freed. See, that would be so nice. Actually, I never even thought of that. The garbage collector is non-deterministic. Um, Finalized registry has a built-in API for this. Oh, there we go. Finalization registry. So I know that many times in code you get some sort of hope, and then when you read it all the way through, you find out, but it doesn't work here. So it looks like there's this thing called registry held console was garbage collected, make object registry. Notes: you can register objects with clean up and then eventually deletes your object. The timing is unpredictable until memory pressure, or not at all. So that's other things that may actually, I guess, not support an older browser, Firefox. And what you can't do is force it, rely. Okay. So you will know. So know when it is deleted, but you don't know if it when it is qualified to be deleted. Yeah, exactly. You nailed it. With finalized, you only know after it has actually collected the object, but time, like, so like, yeah, with my friend, let's say, or with, when he would build something, he may never free up that piece of memory because maybe he has 64K of memory, but his project only uses 5K of memory. So he would never ever, it would never actually need to be cleaned. So yes, you only observe when it's gone, not when it could be gone. So yes, and then it offers to make me a sketch or whatever. Um, and I wonder, is there any way to determine what references exist for an object or array? That is a super insightful, and there's that no, it doesn't. See, that would be kind of cool. Like, you know how I was saying, oh, I'm going to keep a list of parents, and then I'll only delete it if there's no parents. Um, well, you can't ask. You can simulate or debug it in a few ways. Memory profiling, weak ref, finalize ref lets you weak ref lets you peek at object if it's still alive, but it doesn't keep it alive. Oh, oh, but still, that still doesn't do me any good because it's like only if it's not alive. This can be used to test if an object is still reachable. Oh, so that actually, so with weak ref, apparently you can do that. Oh well, I don't have any time. It is 9 o'clock, so I actually should be starting work right now. So I need to go. Happy coding, everybody. I hope you all have a wonderful week. Bye.